Welcome. Today we are learning how to drive Dawson's Westbach equation, and after the revision we'll get this one. So this is loss of air due to friction, a coefficient friction which is a function of Reynolds number, is length of the pipe, velocity of the flow, this is diameter, and this is a G. Everyone knows G. Consider uniform horizontal pipe having a steady flow. The pipe is this one. So this is section 1. This is part 2. So we use the Bernoulli's equation. Bernoulli's equation, which states pressure plus half rho G V squared plus rho G H equals constant. So this one dividing both sides by rho G, it will be pressure over rho G plus V squared over 2G plus H equals constant. Because this now is a constant, and the pressure at this place and this should be constant, so we equate the pressure at this place and this place. The equation will be pressure 1 over rho G plus V squared over 2G plus H1 equals P2 over rho G plus V2 squared over 2G plus H H2 plus HF After calculation, these are the same. You can't cancel each other. And you will be remaining with pressure 1 over rho G equals pressure 2 over rho G plus HF. So HF, which is the head of loss of head to friction, will be P1 minus P2 all over rho G. This will be equation 1. Then we go to the next step, which is finding friction resistance. And now we have the formula of finding friction resistance. Friction resistance is found by friction resistance is found by F, which is times by dl times V squared. This is now pressure. This is a friction resistance, and this is friction force. This is the area of the wet end surface part. This is velocity. Now we should resolve all the forces in horizontal direction. There is forces in horizontal direction at part 1 and part 2. So we should equate all the forces, and the forces in part 1 shall be pressure times area equals pressure 1 times area, or be pressure 1 times area, pressure 2 times area plus F1 plus F, which is friction. This is friction resistance. Then you continue resolving. You resolve this, shall be put all this in the other side, shall be P1A minus P2A equals friction resistance. Putting it outer bracket will be 1 P2 equals this one. And you know friction resistance equals to this one. So you come and equate, and then you divide by in both sides. So you say this, repeat this again, P1 minus P2 equals, you say friction resistance times pi dl times velocity squared all over area. You divide both sides by area. This is cancels each other. They remain like this. After that then you remain with the, by solving this one, we saw at the first is this. After solving, you multiply both sides by rho g, you remain with this. So this one is hf over rho g. So here you say hf over rho g equals this one, friction resistance times pi dl times velocity squared all over area. You resolve both sides to be left with the hf equals friction resistance times pressure times L times V squared all over rho g times area. This is now will be equation 3. This is equation 2. Equation 3. Sorry, equation 3. The other thing now we'll find here is this one and this one. P now PA, that one is perimeter over area, of which is pi d over pi d squared over 4 equals 4 over d. Come here. We come here. We solve this here. We say HF equals F over rho g times 4 over d times L, not 4, L times L times V squared. But what we know, but then by putting F as a coefficient, the HF becomes HF equals F over 2G times 4 over D times L times V squared. Then HF equals 4 FL V squared over D times 2G. This is now the answer. Similar as the one that you show the first time at the derivation is this one now. You have gotten it. Thank you for watching. Please subscribe to join the classes.